Okay, so we're going to go through the binomial theorem and Pascal's triangle. And we're going to use both of those to expand a binomial. Probably the highest expansion of a binomial that you've done so far is probably a plus b. That's a binomial, two terms, to the second power. Okay, and you could FOIL that out, using first, outer, inner, last. You can multiply this out, get a squared plus ab plus ab plus b squared, which will simplify a squared. 1ab plus 1ab is 2ab plus b squared. And what you end up with, you square a binomial, and you end up with what they call a trinomial squared. Every time you square a binomial, you should get at least 3 terms, a trinomial square. The shortcut, you don't have to do all that work if you just square the first term, and you get a squared. Multiply these two together and get ab, and double it would be the 2ab, and then square the last one would be b squared. And if they change the minus sign, change the middle term, you get a squared, square the first one, multiply them together would be a negative ab, and then double it would be a negative 2ab, and then plus b squared. So it just changes this this sign to a minus sign. That's probably the highest expansion that you've done so far. Okay, now what we're going to do in this class is take it to any positive power and expand it out. If I took, like I said, if I said take 2x minus 3y to the 19th power, I could take that and multiply it out, combine like terms. That would take forever. Okay, so there's 2 shortcuts. One's the binomial theorem, and one is Pascal's triangle. Okay, so we're going to go through, I'm going to take you through the formula. You don't have to write this formula down each time, you just have to be able to use it. Okay, so if we take a binomial, a plus b to the n power, okay, it will always start out with that first term to the n power and the second term to the 0 power. That first term is always going to be the a to the n power, b to the 0 power. Okay, plus the coefficient in front of the second term is always that exponent over 1, n over 1. And then a, you depress the exponent by 1, so it's to the n minus 1 power. And for the b, it goes ascending in the exponents. This one was b to the 0, so this one's going to be b to the first. Plus, to get the coefficient in front of the second term, look up here for a minute. You're going to take this exponent times this number in front. Okay, so it's going to be n times n minus 1, and it's all over. You're going to put it over this 1 and increase that bottom number times, so multiply by 2. Okay, that's the coefficient. And then a, you depress this exponent by 1, so it would be to the n minus 2 power. So you're going descending in the a exponents, and you're going ascending in the b's. So it'd be b to the second plus. Okay, now to get the next coefficient, you're going to take this exponent, n minus 2, times the number in front. So up in the numerator, it's going to be n times n minus 1 times n minus 2, and it's all over. Then you're going to take this bottom part and increase the number on the bottom by 1. Okay, and then it's a to what power? Look at these exponents. A to the n minus 3 and b to the b to the third, plus, now show the dot, dot, dot to show you left out terms, and then you need another plus sign. It goes all the way down, and look at this first term. This first term is a to the n, b to the 0. You work this all the way down until you get a to the 0, b to the n. And the coefficient in front is a 1. Okay? Now, you don't have to write that formula down. You just have to be able to apply it. Okay? So let's go through and look at an example. Okay? They will give you directions like this: expand and simplify. And don't take that word too lightly. Simplify means you've got to know the order of operations. You've got to know your positive and negatives. You've got to know how to work with your exponents. This is the binomial theorem. Yep. Okay. Using the binomial theorem. There's actually more to the theorem. That's basically just the formula for it. Okay, so the directions will say expand and simplify using the binomial theorem. Okay, so first problem. Let's say I give you the quantity x plus 2y, and that is to the third power. Okay. Let's go back up for a minute. On the original up here, if this was to the second power, how many terms did we have in our answer? 3. One more than that exponent. So if this is to the third power, how many terms am I going to have? 4. If it was to the 19th power, I'd have 20 terms. Okay, there's always going to be one more term than that exponent. Okay, now, like I said, you don't have to write the formula down, you just have to be able to use it. So, and this is, x is the first term. This is actually, that 2y is my second term inside there. So, okay, so let's go. First term to the n power, and our n is 3. Okay, and then either use parentheses or brackets. 2y to the 0 power. Okay, and I write that down even though I know what's anything to the 0 power? 1. The only exception, 0 to the 0 power is undefined. Okay, plus coefficient in front of the second term is always that exponent, n over 1, so 3 over 1. Okay, and then x to the, now you don't have to write down 3 minus 1. You can just go ahead and simplify it. 3 minus 1 would be 2. Okay, and then 2y to the, you got to go ascending.
Josh Simon, please come to the office.
Plus. Then to get the coefficient in front of the second term, you take this exponent times the number in front. Okay, so it's 3 times 2, and increase the number on the bottom that you're multiplying by, 1 times 2. And then x to the, depress this exponent by 1, x to the first, and 2y to the second, plus. Then you take this exponent times the coefficient in front on the numerator, 3 times 2 times 1, over 1 times 2 times 3, x to the 0, and 2y to the third. And that's when you stop, when you get to the first term to the 0 power, second term to the n power. Now, that's the expand. Now simplify. Okay, so the 2y to the 0 power is 1. So this would just be x to the third plus. Now you always write in algebra, you will always put the coefficient in front of the term. Like I won't write 9x 5y squared. Okay, no, I would write 45xy squared. You always put the coefficient out front. Okay, so that's what we're going to do here. So when you multiply, you got to look, first you got to simplify. 2y to the first power is just 2y. So then we need to take this 2 times this 3 would be 6, and then y to the second, or excuse me, x to the second, y to the first. okay, plus. If you can reduce, you go ahead and reduce it. Okay, so we would reduce the 2's would divide out. Okay, and so we've got a 3 there. Then you need to go ahead and simplify this. 2 squared for 4 times 3 would be 12. We have an x to the first, and this exponent gives us the 4y squared. So there's a y squared. Okay. Then reduce. All of these divide out to 1. They reduce. Don't say they cancel. Canceling means subtraction. Say they reduce or divide out. X to the 0 power. Anything to the 0 power? 1. The only exception, 0 power is undefined. Then 2 to the 3rd power. 2 times 2 times 2 would be 8. Y to the 3rd. Okay? So you should end up with x to the 3rd plus 6x squared y plus 12xy squared plus y to the 3rd. Now, you should go back and look at this a little bit. Look at the exponents on the x. X to the 3rd, x to the 2nd, x to the 1st, x to the 0 if it's not there. Okay, look at the exponents on the y. This would be y to the 0. This would be y to the 1st, y to the 2nd, y to the 3rd. What do all the exponents add up to? If you look at this exponent, x to the 3rd. If you add these up, you'd get to the 3rd. Those would add up to 3. So that's kind of a check. And you should end up with 4 terms. Okay? You'll see a lot of patterns when you do binomial theorem. Okay? So it's not just expand it, it's be able to simplify it. Okay? Okay, now, they may take a long expansion and say just find so many terms. Okay, so I'm going to change the directions on this one. Find the first 4 terms of the binomial expansion A minus, on this use a capital B so it doesn't look like a 6. A minus 2b to the 20th power. Okay? Find the first 4 terms. Okay, the hint on this one first. Change. On the binomial theorem, if you go back up here, on this binomial theorem, this was a plus sign. Okay? So we need this to be a plus sign down here. So change the minus to plus a negative. If it's a minus sign in the expansion, you always want to change it. So we want a plus a negative 2b, and that's to the 20th. I would also say that this is the second term, so use brackets around it. Okay? Find the first 4 terms. If I did not have the binomial theorem, I would be forced to work out that whole problem. That would be awful. Okay? So binomial theorem. You start out with the first term to the n power. Okay, and then times a negative 2b to the 0 power. You always start out with the first term to the n power, second term to the 0 power, plus. Okay. The coefficient in front of the second term is always our exponent over 1. So 20 over 1 in the expansion. Okay, and then it's a to the, go one less, so, yep, 19, yep. And then negative 2b to the first. It goes ascending, yep. Okay, so we've done one, this is one term. This whole thing is the second term. We need 2 more. Okay, plus, to get the coefficient of the third term, you take this exponent times the number in front, So it'd be 20 times 19. And I always increase the number I'm multiplying by on the bottom by 1. 1 times 2. And then a to the 18th and negative 2b to the second. Okay, plus, need to go one more term. So it'd be 20 times 19 times 18 over 1 times 2 times 3. A to the 17th and negative 2b to the third. Okay, and this is our third term. Okay, and then here's our fourth term. We have them, now we have to simplify them. Okay, and like I said, don't take that too lightly. You've got to take your time on that. Negative 2b to the 0 power would just be 1. So first term is a to the 20th. Negative 2b to the first, that would just be like a negative 2. So you have to take a negative 2 times a positive 20. So that'd be a negative 40. A to the 19th, b to the first. Remember those exponents, those two exponents ought to add up to 20. Okay? And then plus. Yep, you got to figure. First you have to do the exponent, then take that negative 2 times this 20. Yep. And then we can reduce. This 2 would divide out, and we'd go into 20 10 times. Okay, and we'd have 190 in front. Then I need to simplify the exponents. Negative 2 squared would be 4. And then I have to take 4 times 10 times 19. Okay, and I end up with 760. And it's a to the 18th and b to the second. Okay, and then plus. Okay, so then I need to reduce. Now, how you reduce this is up to you. I could take the 2 into the 20. I could say 2 times 3 is 6. That's gone. 6 will go into 18 3 times. Just so you get it reduced, you got to take the 20 times 19 times 3. And then you also have to look at the powers here. What's a negative 2 cubed? Negative 8. So we need to take negative 8 times 3 times 19 times 20. Should end up with, then we're going to have to change this because it's a negative. 9,120. And then a to the 17th, b to the third. And then it would be plus dot dot dot. They only want the first 4 terms. One thing that you should notice, if this is a minus sign and we changed it to plus a negative, your sign should alternate. Should go positive, negative, positive, negative, positive. They will alternate. If they don't, you've got an error. If you look at the exponents, a to the 20th, the 19th, the 18th, the 17th, they should go descending order in that first one. And then it would go b to the 0, b to the first, b to the second, b to the third. They go ascending. And if you look at the exponents will always add up to 20. If they don't on that one, they add up to whatever your n value is. Okay? Any questions on that one? Okay.
So you work together.